A very good evening, everyone. Am I audible to all?
Yes, you are audible. Am I audible?
Yes, yes. Very good evening, sir.
Good evening.
Audible,
Good
sir.
evening. Okay, fine. Fine.
So again, a warm welcome and a very good evening to all dignitaries presented today's session. Today, we again welcome our respected resource person, Dr. Atul Juneja, sir, an eminent expert in research methodology, biostatistics, and clinical trials. Sir, distinguished career has left and lasting impact on the field of medical research and education. Sir served as informal scientist F and coordinator of clinical trials registry India CTRI at ICMR New Delhi, where he played a pivotal role in advancing clinical research trials in the country. Currently, Sir imparts his knowledge as a guest faculty at AU Dibya College, Government of NCT Delhi, and serves as a visiting consultant in biostatistics at PSRI Hospital, New Delhi. He also contributes as a visiting faculty member at Nehru Homeopathic College and Hospital, New Delhi. Sir actively contributes to the various scientific committees, including his role as a member of the National Advisory Board for the Journal of Case Reports and participation in the Scientific Advisory Committee, Clinical Research at DSMB of the Central Council for Research in Ayurvedic Sciences, CCRAS, New Delhi. Sir's commitment to disseminating knowledge is reflected in his authored course material for the MPS program at the International Institute of Population Studies. His significant contribution extend beyond the academic realm. He was nominated as the representative of ICMR for an expert committee tasked with providing technical opinion to the Honorable National Green Tribunal regarding the remediation of mercury pollution in Kodaikanal, a role that had a substantial impact. Dr. Juneja sir has played a crucial role in the selection of project posts at the National Institute of Medical Statistics, shaping the institution's research initiatives. He has also been a visiting faculty member at Guru Gobind Singh IP University, New Delhi, where he has been instrumental in teaching research ethics for PhD programs. Sir is presently a faculty member for the MD program for Option Gynae for Research Methodology and Biostatistics, with over 60 publications uh, and including 25 as a first authors, his contribution to the medical research are highly regarded. Such influence reaches beyond national borders with the participation in more than 70 national and international conferences, including invited talks in countries such as USA, Canada, Singapore, China, and Malaysia, etc. So today we are again honored to have Sir with us in this 3 months certificate program. And please join me extending a warm welcome to our respected research person for today's session. And we are starting the inferential statistics today. Please, sir, welcome, sir.
Thank you. Thank you so much, Tiwari Sab, for your very kind and humble words. I'm really humbled with my participation with all of you. At the outset, once again, let me acknowledge and appreciate the efforts of an Institute of Applied Statistics and the collaborating agencies CCRS and Jamnagar. It has been always an honor to be associated with you, and same I feel today also. The topic which has been assigned to me is the testing of hypothesis. In fact, the exact title is Fundamentals of Testing of Hypothesis. Yes, testing of hypothesis. I mean, you must have gone through various, since you're, I understand you are younger faculty or the PhD scholars are doing post graduation. So you must have been exposed to various aspects of testing of hypothesis, which is mainly the statistical tests which you must have been used or intending to use or must have. So all those things become the part of the system, as I always said, that is how you're doing it exactly. What when you are testing an hypothesis, I mean, your focus remains how to do it, which usually the question comes, which test to apply. Usually the students come to us कि कौन सा टेस्ट अप्लाई करना है, क्या है, सिग्निफिकेंस है कि नहीं है. So there are certain basic questions which they are in your mind, and you want to get an answer to those in form of how. I mean, you never get an answer in form of you don't get means, I mean, you don't come out with those questions because you have not been exposed to that. You know how to do it. You know how to apply the test of significance. You know how to apply t-test, chi-square test. All thing, of course, you will be exposed to through various lectures, coming lectures. But there is a base being associated to all these the procedures. So as I have mentioned in my last lecture also, I always believe in why first before going to how. You can enjoy how when you know why, because when you are doing something, when I mean, it's good to do something and you can be expert in the computer analysis and all those things, you can do it, but many times we don't focus on what we are doing. We say, oh, significant aa gaya result, good, you're happy. What has happened in the background many times gets missed. So I would say that testing of hypothesis is basically the base of the statistics, because as I have already mentioned that all the contents in the presentation are linked to other lectures also. So it is like a train bogie, that one bogie is linked to another. So you cannot move in isolation. So all the things which would be the terminologies would be coming, you would be it would be useful to you in form of exams, in form of viva, in form of selection for your uh, careers to come, and what you are doing, why you are doing. So this gets linked. So the topic which has been assigned to me, I really appreciate and thank the organizers and the who have set the trend, that it is important to talk basics of the testing of hypothesis, and then we come to test of significance, parametric test, non-parametric test, correlation, and all those things. You can do it. So I'll try to focus on. So as I have already mentioned you and all expressed in my earlier lectures also, my slides are linked. So there might be many things which might be basic and you might be knowing, and might be a repetition of what I have done in earlier lecture or other repetition of earlier teachers. So bear with that. But since they are used to link the topic, so let's get on to the business. And so the basic slide which I always tell the students, because this is what I have felt being in the medical line. Somewhere initially, nothing, I mean, against anybody, nothing wrong in it, because the biological researcher, medical researchers, they have been a bit shy. They have been shying away from the subject of statistics, or to put it more broadly, mathematics. They say we left the subject in the school days at the 12th just because we were not interested. But the fact remains that mathematics can never leave you. Ultimately, it is the objectivity, it is the measurement what helps you to take a decision. So, as a doctor, as a clinician, as a researcher, you have to have objectivity to making a decisions. So, anybody, I mean, I can just tell you, anybody who is a medical researcher and you know more about epidemiology and statistics, you stand taller. Believe me, this is the experience I have gained. Like if I put it myself, uh, I'm basically from statistics background. Statistics background means I'm basically a mathematician. But understanding the medical line, understanding the medical statistics, understanding the biology of the subject always helps me to interact better with the medical researchers, because I know their terminologies, I know their intent of the questions. Many times they ask the question, significant hai ki nahi hai? So, I mean, they never, I mean, get into that thought process of significance of what, whether you're talking about a categorical variable or you're talking about a continuous variable, what is the outcome variable on which you wish to say that it is significant or not. So these are all the things which we need also to understand from them, and they also need to understand, and then accordingly the things can move better. So my slides are, there might be some. So it's all about, it's a good sentence I have always mentioned in all my presentations. It's all about interdisciplinary competence to stand tall. If you know something else, you stand tall. So as a statistician, if I know concepts of medical science and their uh, research thought process, I can put them into objectives more efficiently and help them. So it's always being together, which always, like we say, we is always better than I. Like, so important to understand the concept behind the theory to have a sustained knowledge. I have always mentioned, I always mention in my classes wherever I go, that knowledge has to be sustainable. It is not that कि आपने पढ़ लिया and then exam pass हो गए, बढ़िया number आ गए, छुट्टी. Always sustainable means sustainable forever. You may not remember the formulas, but what those formulas were doing for you, that you're supposed to remember. It goes with any science. So it's very important. The last sentence in red says it's important to formulate a question than the answering one. Why have put this line on this? When we interact with PG scholars, the, I mean, usually what is missing? The objectivity to a question is missing. Oh, I'm doing this clinical trial. I want to see the efficacy of this drug. When we ask which is the outcome variable, then the answers are not very clear. We want to see the improvement in hemoglobin level. We want to see the improvement in HbA1c. We want to see the improvement in uh, the parameter, whatever they're concerned. But the exact answer, that means the exact outcome variable, what they expected to be called as efficient, what they expected to be called as success is missing. So all these questions, when they ask those questions to us, we try to make them in an objective way. So when if any researcher comes with those objective questions, the interaction gets easier and more crispier, and a better results from the epidemiologist or statistician come up. So always remember how to put a question. And again, I mean, if I have to ask you as a medical person, if I am not well, I have to be very clear in my question. Not well means what does it mean? Not well means there's some problem in my leg, so I have to tell there's a swelling in the morning or something. So it's the same things. The questions have to come from the researcher so that exactly the statistical aspects can be dealt accordingly. So these are, I mean, general things. I hope you don't mind my frankness on this matter, and these are experiences which I have gained and trying to share. So, this slide, I think I showed you the last time also, but still there are reminders: lies, damn lies, and statistics. This is the problem. This situation, not the problem, this situation arises because when the subject is not properly utilized, lack of experience on both the sides, user side and the giver side. So when you are very clear with the question, the answers are also very clear. Then, of course, the slide goes off. So next. So we have been talking about the testing of hypothesis. We'll come to the exact definitions of, as I have already told you, I'll be talking general, but the slides or the content of the slides which would be flashed to you would have a standard language. So both of the things are important. While writing, you need to have a standard language, but while talking, we need to be expressive. I've always told that when you are appearing for an viva, the examiner is more concerned how much you know. When you are writing for an examination, the examiner is more concerned how well you have written. You might be right, but if you have not written well, there would be deductions in your marks and all. So I'll try to put the things in as simple as I've always tried to do, to the standard statistical approach, what will be going through. So always test your assumptions. This is just a general slide, not from any statistics point of view. You think something that this happens. Forget about the medical research. Anything you're thinking, you need to test it. आप सोचते हैं कि ऐसा होगा, हम यहाँ जाएंगे तो वहाँ हम घूमने जा रहे हैं तो किसी भी स्टेशन पे, what we are likely to get there. So we need to have some data through internet or through our friends, and we then try to make an assumptions. And then when we go there, we test it, whether it happened or not. So that means the evidences have to be generated for testing the and there are procedures when the evidences on the objective variables are tested. That is where the statistics helps you. Like, for example, there might be a repetition of my examples. Suppose there is a class of students, they have scored 55% marks in research methodology. There's another class which has scored 57%. Then the other group says, oh, we have scored better, 57% average score. Then somebody says, hardly matters, 55 or 57 mein kya farak hai? So now this becomes an argument. But here, the objectivity from the statistics, from the testing of hypothesis, through a standard methodology, tells you whether this 57 is different from 55 or not. So that is the basic purpose of this presentation, so that you know when you're comparing two things, two figures, two magnitudes, whether they are mathematically, if you talk in terms of mathematics, 55% and 55.25%, they are different. It's for when you put it in a mathematically, you have to put not equal to sign. But when it comes to statistics testing, it's then you have to see whether this is just a matter of chance that somebody has scored 57% or 56%. Otherwise, it is as good as what the people of the other class or the students of other class 55% have scored. So this is where your testing of hypothesis and the procedures associated further through test of significance comes for you to risky. So the formulas, of course, the uh, calculation part, the statisticians would be there with all of you to help you, but you need to be clear with your objective question, what you're looking for. If you're not clear, the statistician may not be able to imagine what is, and there could be a wrong interpretation of the results. So that is why all these things have been put in the initial introductory slides and reminders from my side too. So statistics is a probabilistic science based on nature's principle. So this always keep it in mind. There is nothing very hardcore. When you say that the doctor says that you will be fine with this drug, there is a probability associated. He says, "Oh, don't worry, you'll be fine." When he's saying, "Don't worry, you'll be fine," that means there is a high probability which is assigned to it. And many times he says, "कि दवाई लेके दो देखते हैं." That means somewhere at the back of mind, he's feeling that the chance of getting cured with this medicine is something like 20 to 25%. So these objectivities, then the statistics would help that what is the chance that it is going. So it is based on all nature's principles. So normal distribution आपने अगर पढ़ा होगा या पढ़ेंगे, so normal distribution क्या है? It's a nature's law. This is how the data is distributed. I'll not get into that serious business right now, but just remember normal हम क्यों बोलते हैं? Normal means this is how the nature has distributed the values, that it is spread like this, and उसी के बेस पे सारा statistics का test of significance सब कुछ बना है कि नेचर में वैल्यूज इस तरह से स्प्रेड होती हैं कि उसका कर्व इतना होता है, मीन प्लस माइनस 2 स्टैंडर्ड डेविएशन मेक्स 95% ऑफ द वैल्यूज, उसका पीकेडनेस नॉर्मल की कितनी होती है. सो दैट इज व्हाई इट इज कॉल्ड नेचर्स प्रिंसिपल, कि नेचर से देखा गया ये, साइंस ने नहीं सोचा, साइंस ने ऑब्जर्व किया उसको. नेक्स्ट. So what is desired from a research? It's formulate a right question. कहते हैं ना, getting question what you want to do from a research is the biggest challenge. Then making it title of the project is another challenge. Then objectives. उसके बाद तो methodology etc. is not that difficult. The rationale of the study, any program, rationale of the research is most important of the contents. But before coming to the contents, what you want to do. So that means what is your question exactly? Question means again coming back to those variable business, you need to understand that what you are doing, how you're going to measure it, and what kind of variables you are going to run. So I'm reminding that I always identify the variables. Qualitative hai ke quantitative hai. We have dealt earlier in my lecture as well as must have been done through earlier lectures also. So कौन सा variable है and हम किसको success मानेंगे कि ऐसा होगा तो we would say this is a success. So these things have to be very clear from the researcher's point of view. Then that bucket he takes it to the statistician where he can help you. If you're not clear with those things, then it will be guesswork by the other person, and if that guess might go haywire. So again, a linking of the certain things and the reminding of things. Since you're all much younger to me, so I'm taking the liberty of putting you to all these things. Next. So what is the basic scientific approach? क्या होती है? Observing phenomena, knowing more about it through books, coming out with a thought process. अभी देखिए, आप सोचेंगे स्लाइड क्यों डाली? हमारा टाइटल क्या था? टेस्टिंग ऑफ हाइपोथेसिस. हाइपोथेसिस क्या है? Hypothesis is a scientific word, but hypothesis is your thought process basically. What is going to happen if you do that? That's your hypothesis. So coming out with the thought process of happening or not happening. So Newton's apple theory, because Newton observed that the apple is falling down, and many people must have observed, but nobody thought that why is it happening? Because everybody thought It is natural. The question, so science, what is a science? That always you have what you observe, you have to have the things in your mind. Why is it happening? Even if it is a simple thing. If you're not getting an answer, then it becomes a research question. Research question which you can get an answer through literature, or if not literature, then you can do a research on it. So then finally it comes hypothesizing a thought process. What hypothesis means? What has led to what, or what is the outcome if this is happening? So experimenting and replicating. If you have done something, if you think something, if you're able to replicate and get the similar results, that means consistency of the results. What you thought is going right, or it is not, it is other way around. That means your hypothesis is getting accepted or rejected. So experimenting and replicating means you're doing something. Suppose I'm again coming back to those design of studies and all. Suppose you have cured a one patient and you feel very happy that it was a difficult case and you gave this medicine and the patient got cured and you were excited. So you say that, okay, if this is a medicine, this medicine works mm, for this disease. No, the science won't accept that. You have to replicate it. In this situation, you can present your data of that particular patient in form of a case study. But the science would answer that, is it going to happen with others? If this has happened with him, then you select the similar patients and try to do a research, and then you get, and there the statistics helps you whether you met the success based on the criteria, based on the variable you identify through the measurements. Measurements, again, I repeat, measurements of qualitative nature, quantitative nature, and accordingly, the statistical analysis follows. So it is not, the statistics does not move in isolation. It moves with your intent, what you intend to do, and then accordingly the statistician helps you. So this is a link. So we need to understand you, and you need to understand the subject. Understand means just concept. Okay. So providing the evidence, ultimately, what you have thought is providing evidence comes through statistical help. Statistical, many times we will call statistical, laga dete hain, statistical jugglery. No, it is not jugglery. Laga dete nahi. It is a science. You, based on your objective, you put that subject and get an evidence of clear yes or no. So what you thought is happening or not. It is through testing of hypothesis. This is the whole concept behind the testing of hypothesis. And how will be done? Next, please. So type of research, just again a repeat slide. Inductive research, deductive research, we've talked about it. Inductive means it's your thought process. Deductive means something is already there with the science. You're getting it, getting an evidence to it. So most of the time in the traditional system of medicine, what happens? You have certain practices which are available in the standard text, classical text, but many times the research wants the evidence. So you observe that phenomena, what is there in the classical text, and put into practice and generate a data. So that's called evidence. And you say, yes, this is happening. If it doesn't happen, obviously, then you can say if it is there in the text, but we are not observed it. So, okay, next. Take health statistics means when you are dealing with health, statistics comes into role in right from space science to agricultural science, industrial science, everywhere no discipline is there one can think of without statistics. For example, if we recollect the unfortunate event of Kalpana Chawla, and the spacecraft got attacked by some atmospheric particles. The probabilities were worked out at that stage also. The probability was very low. It was something like 0.003, something like that. But it was not zero. That there's a possibility. But they maintain the speed and all those things, all their science comes into picture. But that probability still remains. They try to minimize that probability. Let me tell you, the probability cannot be made as zero. The normal distribution is from minus infinity to plus infinity. Always remember this. This I have been repeating in a number of lectures and in my interactions with physical or the online. So there was a low probability, but that happened. But with that lower probability, they take a decision to go ahead with the event. Suppose you feel that this drug might have some adverse effects, there's 5 to 7%, but you feel that this will yield a better result. So considering the gain and losses, the ratio of gain and losses, you take a decision. It will never be like that the probability of this will be 0. So the testing of hypothesis always says that based on the statistical results, your probability will never be 1, will never be 0. You need to minimize the uncertainty and take a call. ठीक है, आप p less than 0.05 देखते हैं, तो that 0.05 is a uncertainty margin. So you go ahead with considering it as significant. We'll try to come in the next slides. So ये हम जो चल रहे हैं जो टेस्टिंग ऑफ हाइपोथेसिस, जस्ट टू रिमाइंड यू, तिवारी साहब ने भी बोला था कि दिस इज पार्ट ऑफ इन्फरेंशियल स्टैटिस्टिक्स. जो हम जब सेंट्रल टेंडेंसीज, मेजर ऑफ डिस्पर्शन, व्हेन वी रीड, दे आर डिस्क्रिप्टिव मेजर्स, डिस्क्रिप्टिव स्टैटिस्टिक्स. Simple, nothing very big science about it. Descriptive means you're describing something. The diabetes की prevalence 20% है, बस, that's all. And when you make an inference that national average is 10% and in this region it is 25%, is this difference or is this a matter of concern? Then the inference comes up. The statistical hypothesis made and then the procedures attached to it, computations attached to it, would tell you that 25 is significantly higher than 10%. So there the statistics is seen in form of inferential statistics. So that is what I feel. We have started with inferential, and the test of significance, parametric test and non-parametric test, would follow in the next lectures. So steps in conduct of research: planning, execution, and the first and foremost always remember is research question, which is most challenging. क्योंकि उसमें क्या करना है ये बड़ा, हम सोचते हैं we would like to work on diabetes, we would like to work on hypertension, but what to do, what we have to do. So this comes up only with the interaction with your seniors, with your juniors, with your peer group. Then you say कि चलो ये करके देखते हैं. तो ऐसा नहीं है कि रिसर्च क्वेश्चन के लिए it has to have a very big scientific technical environment around you. You observe the things around, talk to people, and talk to your seniors, talk to your senior PGs, and then say, okay, let me do this thing, and then get on to the question clearly and the objectives with the variables. I emphasize always remember the variable always, because when I am interacting, the concept of variable is always missing. कि हम ये देख रहे हैं ठीक होगा कि नहीं होगा, कैसे पता लग रहा है ठीक होगा कि नहीं होगा, कि उसको हम उसका हीमोग्लोबिन मेजर करेंगे या उसके सिम्टम्स पे देखेंगे. So that is a decision you have to take, and according the variable can be decided. Next slide. So key points of your proposal: what is your question, why is your study important, and how you're going to do it. How you're going to do it is important, no doubt about it, but if your first 2 points are well taken care of, the third can be edited very easily. But if your why is your study important, if you lack somewhere here, there is a possibility the other person may not be able to help you, and in the end, if your intent of the research is questioned, the whole thing goes waste. Whole statistical analysis, whole your exercise, physical exercise, scientific exercise you have done through goes waste. So you need to say, if you're doing a study, why it is important. So suppose if it is a clinical trial, always the first intent of the clinical trial is that the interventional drug, what you are trying to do, is going to do much more help than harm. If you're not very sure what is going to happen, the ethics committee won't allow you to do that. So you have to have some reasons. Ultimately, your results might be in a different way, but you need to have a good rationale behind it, why we're doing it, and you feel that if this drug is used for this purpose, this will help. You need to have a clear text or the other research supported by it, and then you go ahead. If you have very limited answer to those questions of why your study important, even if it is passed through ethics committee, tomorrow the results might be questioned. Next, please. So research design, again a reminder कि किस टाइप की स्टडी है. टेस्टिंग ऑफ हाइपोथेसिस में आप सोच रहे हैं कि डिजाइन की बात हो रही है. टेस्टिंग ऑफ हाइपोथेसिस में किस टाइप का डिजाइन है, उस हिसाब से हमारा एनालिसिस और वेरिएबल यूज होंगे. ठीक है. If you want to need find out a frequency or a burden of a disease, cross-sectional surveys, यानी कि descriptive observational studies होंगी. Risk factors, case control study, quad study. Of course, the details would be taken care of in some other lecture, but just a reminder. Determine the prognosis of a disease. It's a quad study. If you want to see the efficacy or effectiveness of a drug, clinical trials are important, community interventions are important, and evaluation of community programs, evaluation studies. ठीक है. If effectiveness and efficacy का difference, I hope you know it. Let me just tell you, because अभी recently एक research methodology के question में आया हुआ था, what is the difference between people know it, but many times they are not able to put it into the words while it comes in examination. Efficacy is on the test conditions, effectiveness is a routine use. If you are treating a patient and observing that you treated 20 patients in 1 month, and out of 20, 10 got cured. So this is your effectiveness, because this was based on your standard of care. Suppose if you conduct a clinical trial and then see what are the results, then it becomes an efficacy. Like a motorbike gives a mileage of, you get an ad, see an ad, it says a mileage of 100 kilometers in 1 liter. And niche it is mentioned under test conditions. So there it is the efficacy of the engine. But if you're suppose using your car or a motorbike every day, and I mean you get an average also on that on your screen, that average is something like uh, for a car 12 kilometers or 18 kilometers, 15 kilometers. So that is effectiveness, because you're routinely using it and observing one. So this is the difference between efficacy, and this was a question recently in one of the research methodology, and many students unfortunately could not answer actually. Doesn't matter, but so research process is goes like objective, then it starts with research question, then objectives, then research design, and then how to do the sampling, sample size, data collection, data analysis पे जब बात शुरू होगी तो टेस्टिंग द हाइपोथेसिस. दिस लेक्चर हम टेस्टिंग द हाइपोथेसिस क्या है उसके बारे में बात कर रहे हैं, कैसे करना आगे चलेंगे. और उसके बाद interpretation is very important. This interpretation is important in the sense, when you understand the concept behind testing of hypothesis, you will be in a better position to interpret. Else you will be only left with somebody else's opinion. You give it to a statistician, he says significant hai, significant nahi hai. You don't know what actually it means in terms of clinical outcomes. So of course those things can be discussed in more general forum. I'm just hinting all those things, that interpretation is very important, whatever kind of results you have got. It is not only that only talking about significance and not significance based on statistics. The clinical factors do come into picture, and how to write it, there the statistician, epidemiologist would help you. And then this is only possible when you understand the results. If you're only dependent that somebody has done it and it has and given some results through testing of hypothesis, and these are results, and you don't understand what it is, so that won't help you to. Next, please. So this is just a statistical inference. हम क्या करते हैं? We always, why if a statistical inference? That means whenever whatever data we are generating, it is based on a sample. That means there is some bigger population behind it on which we want to base our results. ज्यादातर ऐसे ही होता है ना. अगर आपने कोई clinical trial किया है, तो you are saying that this drug is good in terms of efficacy based on these outcomes. Outcomes means repeat those variables क्या थे उसके करके. So that means then it goes for approval to drug controller general, and finally the drug is launched. So that means bigger population, that means the people who are affected with that disease would get benefited from this. So this small sample of the clinical trial. So you always remember that कोवैक्सीन का कोविशील्ड का ट्रायल हुआ था different states में थोड़ा थोड़ा sample लेके, because it was an urgency, and then and ultimately it was felt that it will help the bigger population. So ultimately we're dealing with sample. So there, how good is sample, how well it is representative of the population. So that means there the sampling techniques come into picture. So that's what I told you in the very beginning, that everything is connected. You think कि testing of hypothesis आज पढ़ा, कल आपने sampling techniques पढ़ लिया तो ठीक है, they are too independent. No, they are not independent. Everything gets a connect to each other. So I always try to remind and revise or connect the subject. So random sample आपने लिया है, random means क्यों हम बोल रहे हैं? It's a representative. So because you have to judge your results through testing of hypothesis on a bigger way. Okay, next. So that's again basic slide with which Tiwari ji started. Statistics, descriptive, inferential, and hypothesis testing. Just a reminder. Next. So इसमें देखिए statistical estimation में क्या क्या आता है? Point estimation. आपने sample लिया, proportion, relative risk, odds ratio. I mean these are few basic measures. So these are, suppose आपने average लिया, arithmetic average लिया, and you say the average blood pressure in this region is average systolic blood pressure is say 135. Fine, बढ़िया, आपने सैम्पलिंग अच्छी की है, सब कुछ ठीक है. बट इज दैट एनफ? 125 का क्या मतलब है? हम उसका स्टैंडर्ड डिविएशन देखेंगे, बट स्टिल विल नॉट बी एबल टू कंक्लूड व्हाट. भाई पॉपुलेशन के लिए, हम पूरी पॉपुलेशन के लिए ये 135 ही मान लें क्या? देन वी कम टू इंटरवल एस्टिमेट. 95% confidence interval is a very popular term and most of you must be knowing it, what it is, but still I'll repeat it. So that means 95% confidence interval अगर हमने निकाला, ठीक है, 99 भी निकाल सकते हैं. That means there is 95% chance that the population value is likely to lie between this and this. So we are more sure about, then that means we have moved from point to range कि भाई इसके बीच में ये वैल्यूज हैं. सपोज वो रेंज बहुत बड़ी है, एवरेज हमारा आया ब्लड प्रेशर 135, ठीक है. हेलो, एम आई नॉट ऑडिबल?
Audible, sir. Audible, sir.
अच्छा, ठीक ठीक, because somebody mentioned so.
Audible, sir.
Okay. So we have come to interval estimate. So that suppose we were talking about 135 mm of mercury, right? You feel okay, average blood pressure systolic of the people, adult population, ठीक है, चलेगा. But now when if you calculate the confidence intervals, okay, suppose you get a value from say 110 to 180, just hypothetical. So now it is not easier for a program person to absorb what to do, because the population values are likely to range between. So that means this population contain many people who have a normal blood pressure, and there are big number which might be having hypertension. So because the range is too big, so accordingly this range tells us where we are likely to. ठीक है, so confidence interval is an interval estimate, it tells you. इसका मतलब क्या होता है, सिंपल बताता हूं आपको. Message ये है, the population value lies between this and this. There's a 95% chance if you are computing 95% confidence interval. If it is not mentioned by default, it is understood that it is 95%, but you can calculate. Let me just take a call.
Yes, yes.
हेलो हेलो, जय श्री राम. हाँ बताइए. हाँ हाँ बताइए बताइए. नहीं, मैं मीटिंग में हूँ किसी. बाद में बात करता हूँ, ठीक है. फ्रेंड्स, सॉरी फॉर द इनकन्वीनियंस. आई ऑलवेज बिलीव इन टेकिंग द कॉल, कि हो सकता है किसी की जरूरत हो सकता है मेरी
Yes,
जरूरत
yes,
हो.
sir.
सो दिस इज माय, सॉरी फॉर द
No
इनकन्वीनियंस.
problem, sir. No problem, sir.
So narrower the confidence interval, the more precise the point estimate. सिंपल सी बात है कि आपने सपोज 135 आपका एवरेज आया और आपका कॉन्फिडेंस इंटरवल आया 120 से 145. So you can feel okay, now we can proceed that our 95% population is likely to lie between 125 and 145. So इससे हमें statistical significance भी पता लग जाती है. Anyway, we'll come to it later. Next. So research question and hypothesis. This is the slide which is flashing on your screen. We have talked whole theory, whole story about it. Now let's try to read it in a more objective way. That's what we started with. Of course, I've been talking general things, but finally one has to converge to objectivity. The research question, sometimes called the problem statement, presents the idea to be examined in a study. So these are the questions which are asked in exams also. I'm just hinting you. So if you're appearing for any exam, it is a foundation of the research study. Hypothesis attempts to answer the research question. What you have thought, hypothesis provides the justification for a clinical trial. आपने ट्रायल किया, हाइपोथेसिस के थ्रू ही वो प्रूव होगा, क्योंकि वो तभी पॉसिबल है व्हेन यू हैव क्लियर ऑब्जेक्टिव आउटकम वेरिएबल्स, क्लियर inclusion criteria, homogeneous population, that if drug is working and representative population, यानी कि राइट सैंपल लिया है, सो अगर इस पे काम कर रही है तो इट विल वर्क इन अ बिगर population also, and that answer comes in terms of magnitude, not in terms of feeling or in terms of general assessment. Yes, general assessment is important. Doctors many times feels that okay, this drug works better, but ultimately you need to have an objective figure to it. So hypothesis testing is the most widely employed method of determining whether the outcome of any research is positive or negative. कैसा हो रहा है कि नहीं हो रहा. Next, research hypothesis. दो hypothesis होती हैं, अब हम और specific हो गए. Research hypothesis is a statement of an expected or a predicted relationship between two or more variables. देखिए मैंने कहा ना आपको कि हम जनरल बातचीत से स्टार्ट हुए थे, अब ऑब्जेक्टिविटी पे आ गए. इट इज व्हाट एक्सपेरिमेंटल बिलीव्स विल हैपन इन दिस रिसर्च स्टडी. इट इज रिफ्लेक्टेड इन एम्स एंड ऑब्जेक्टिव्स. Suppose he feels that this, suppose a drug which is already there, like a standard of care, the success rate of standard of care is say 50%. Okay, now the new researcher says, I've come out with a new drug, let's try this. This is likely to yield 60% success. This is what a researcher hypothesis thinks in terms of objectivity and in terms of variable. कि 50% already है, my drug is likely to prove 60%, and he or she needs to have a justification to that through which is reflected in the rationale of the study. So this is the research hypothesis. Now, when the data is generated and put to the statistical churning methodology based on certain principles, those principles we'll talk I will not talk about the methodology, but the principles of force we'll talk. So then another hypothesis arises, which is called statistical hypothesis. Research hypothesis says that the new drug is 60%, the standard of care is 50%. So 60% is more than 50%. This is the research hypothesis. Now comes the statistical hypothesis. The statistics says, not statistician, the statistics says 60-50 बराबर हैं दोनों. Now let's see. It says कुछ नहीं फर्क 60 और 50 में. Another hypothesis is generated which nullifies the researcher's hypothesis. It says 60, and when you put it in actual terminologies, 60% is same as 50%. The mathematics would react, अरे क्या लिख रहे हो, 50% is 60. But statistical hypothesis says कि हमें जो 60% दिख रहा है वो वैसे ही है, it's a matter of chance. Then our analysis, all the procedures which will be dealt later, will tell whether this 60 is different from 50 or not. We need to consider that based on that normal distribution and all those things. Next, please. So requirements for a testable, it must be possible to prove an hypothesis. That means objective variable hona chahiye. It must be possible to prove the hypothesis is false. Yes. Objectivity से ही होगा ना, वैल्यू इधर आएगी या उधर आएगी. तो अभी कई चीजें हो सकता है आपको ना उतना comfortable लग रही हो, but when we move ahead with more lectures, you will feel that, oh, you knew it earlier. It must be possible to reproduce the results of the hypothesis. That means we have replicated. That means there's a good chance that the results are likely to be revealed in a bigger population also. Next. How to propose a testable hypothesis. Try to write the hypothesis in an if and then statement. If you take an action, then a certain outcome is expected. Like giving medicine an outcome. You're giving a medicine, you expect that the patient will improve. In overall, if you give it to 100 people, 60 are likely to improve. So this is what you're giving, you're expecting. And improve means it is a clear, it could be a or the qualitative means through based on symptoms, signs and symptoms, or it could be based on the biological parameters or biochemical parameters. Okay, if the blood pressure comes down from 150 to 140, you will call it a success. But if it comes from 150 to 145, you don't call it a success. So you have to clearly define. So you say how many got success or not. So this is all you have to clearly state in the beginning. So write an hypothesis in such a way that you can prove or disprove it. Be specific, like vitamin B deficiency can cause cervical cancer and not nutritional deficiency causes cervical cancer. This is a bigger statement. So you need to be specific. So identify the independent and dependent variables. So understanding of the variable and statistics is very important. Independent dependent का क्या मतलब हुआ? Intervention दिया आपने, that is a independent variable. Outcome, whether the patient got cured or not. So this is how this is translating to the outcome. So your outcome is success based on certain things. So उस हिसाब से हम, so whole analysis, regression analysis, all major analysis, correlation analysis, multivariate analysis, they can be done most efficiently when you're very clear with the variables. So many times in the end you intend to use certain variables as continuous, but initially while collecting the data you have used it in qualitative form, then nothing can be done. So I repeat that selection of variables I have told in earlier lecture also, that you need to have a very clear concept. Suppose you're, I think repeat the example just for reminder. Suppose somebody asks the hospital that how many people, geriatric population, people are coming to your clinic. So data is generated, it is simply said, geriatric, yes or no. So if it is above 60, comes in the geriatric category, and you generated data that 100 people came and 30 were from the geriatric side. So 30% हो गया simple. But now if somebody asks you कि इसमें 70 के एज के ऊपर के कितने थे, आपने तो डेटा कलेक्ट किया, geriatric है या नहीं है, in form of binary, the variable was binary, geriatric yes or no. So if somebody asks you 70 के ऊपर कितने थे, आपके पास जवाब नहीं होगा. So you need to have an understanding in the beginning and foresee what could be the requirement and collect the data through continuous variable. कि exact age note कर लो, and then 60 के ऊपर कितने थे, 70 के ऊपर, computer आराम से help कर देगा आपकी. So identifying independent and dependent variable is an important part of whole statistics. So hypothesis भी तभी चलेगी अगर आप लास्ट में पता लगा कि आपने वेरिएबल ही ठीक नहीं लिया. Next. A non-testable hypothesis is a claim that cannot be tested. Non-testable hypothesis can occur in single claim or in an argument involving multiple claims. If not written in testable form. Example, it doesn't matter whether or not you skip a class. Intent तो समझ आ रहा है. That means somebody is telling you कि class attend करो ना करो कोई फर्क नहीं पड़ने लगा. इसका क्या मतलब है कि maybe just on a lighter note कि वो ये टीचर कोई ऐसे ही पढ़ाता है, अटेंड करो या ना करो, नंबरों पे कोई फर्क नहीं पड़ने. So ऐसा नहीं है, इसको टेस्ट नहीं कर सकते. So it can be tested. Those who skipped the class, what average they got, those who did not skip, what average they got, and this can be compared. But the hypothesis is not written in this way, it can be tested. It has to be very clear that if you are going to lose marks if you skip the class, you're not going to do well. So here it doesn't matter. Doesn't matter का क्या मतलब हो? So these are the things. You have an intent to do some research, but you're not able to put in an objective way. So ultraviolet light could cause cancer. No, this doesn't work. Your hypothesis is that when you feel that ऐसा होता है, so you'll say ultraviolet light causes cancer. Now it has to be tested. It does or doesn't, based on probabilities. Remember this thing. It is not that you say this drug is working, so it's 100%. So there the type 1 and type 2 errors come in picture. So dog makes a better pet than cat. ठीक है, somebody says कि proof कैसे करेंगे? But what is lacking in this? The variable is lacking. Better in what way? So you have to define. You say better in what way? So suppose again on a lighter note, चीजें lighter बात करके याद रह जाती हैं. Suppose I mean if you've left the milk on a table, how many times where the dog is there, the utensil is disturbed. Now, how many times the utensil is disturbed when there's a cat? So this can be compared. The proportions can be compared. So it has to have an objectivity. So these are non-testable hypotheses, but the intent in the mind is tested for testing. But the lacking aspect is the variable. So next. Descriptive inferential मैंने बता दिया. Next. सो सैंपल साइज कंसिडरेशंस बड़े इंपॉर्टेंट होते हैं, जिसमें जस्ट एक रिमाइंडर स्लाइड है, ताकि आपको अगर सैंपल साइज निकालना होता है तो ऑफ कोर्स यू विल हैव सैंपल साइज लेक्चर्स इन योर प्रोग्राम और मस्ट हैव हैड. सो दीज आर द थिंग्स. जस्ट एक रिमाइंडर स्लाइड है ये कि आपको क्या क्या चाहिए होता है. टाइप 1 एरर, टाइप 2 एरर, एक्सेप्टेबल एरर मार्जिन एंड द इफेक्ट साइज व्हाट यू एक्सपेक्ट इफ यू कंपेयरिंग टू थिंग्स. तो ठीक है, मैं अभी ज्यादा नहीं जाऊंगा इसमें. नेक्स्ट. सो रिसर्चर्स पॉइंट ऑफ व्यू, जो कहते हैं ना, अब वहां पे हमारे एक हमने नल हाइपोथेसिस बनाई थी, तो जो उसकी ऑल्टरनेट होती है वो रिसर्चर की हाइपोथेसिस होती है. तो ऑल्टरनेट हाइपोथेसिस एंड द रिसर्चर्स हाइपोथेसिस. स्टैटिस्टिक्स ने क्या किया? स्टैटिस्टिशियन ने नहीं, ऑलवेज रिमेंबर, स्टैटिस्टिक्स ने क्या किया? आपके क्लेम को नलिफाई कर दिया. तो जो उसका क्लेम था दैट बिकम्स ऑल्टरनेटिव. It says the 50% example, coming back to that 50%, 60%, 50% efficacy of drug is same as 60%. कुछ नहीं फर्क, हमें 60 दिख रहा है, but it is not making any difference. But researcher feels that 60% is really more. Then those calculations based on certain basis tell you whether the 60 is more. And again, remember, this 60 is more than 50 or not is not in absolute terms. In absolute terms means it has a probability attached to it and the sample size attached to it. Suppose if it is a small sample, the 60 might be same as 50. But if it is a bigger sample, the 60% is more than 50%. Maybe the future, like some of you might be knowing, or maybe more lecture would throw a better light on this. Next. So देखिए, ये सारा उसी प्रोसेस पे हम आ रहे हैं, चलते चलते हम इस पे आ गए. ठीक है. So good hypothesis will be clear, avoid moral judgments, be specific, be objective, relevant to the research question. Many times objectivity तो होती है, कई बार हमने देखा है प्रोटोकॉल में ऑब्जेक्टिविटी बड़ी क्लियर है, बट रिसर्च हाइपोथेसिस की, बट वो ऑब्जेक्टिव में रिफ्लेक्ट ही नहीं हो रही है, टाइटल में रिफ्लेक्ट नहीं हो रही. So these are the things in a broader sense one has to keep in mind. So this, next. Please remember, absence of evidence is not the evidence of absence. ये टेस्टिंग ऑफ हाइपोथेसिस की सबसे बड़ी थ्योरी है. अब आपको लगेगा कि क्या लिखा हुआ है, इसका मतलब क्या है. मतलब इसका मतलब सिंपल अगर मैं बोलूं, टेक्निकली हम स्लोली मूव करेंगे, या और टीचर्स भी आगे फर्दर मूव करेंगे उसमें. एब्सेंस ऑफ एविडेंस, आपने हाइपोथेसिस को टेस्ट किया. सिंपल बता रहा हूं, अभी उसको स्टैटिस्टिक्स को थोड़ा सा भूल जाइए. कि सपोज दैट, कमिंग बैक टू सेम एग्जांपल, 60% का क्लेम था एफिकेसी का एक रिसर्चर का, दूसरे का 50% था. ठीक है. नल हाइपोथेसिस थी 60 एंड 50 आर सेम. एक रिजल्ट आता है आपका सिग्निफिकेंट, स्टैटिस्टिकली सिग्निफिकेंट कैसे आएगा वो बात की बात है. दैट मींस 60% दिस ड्रग वर्क्स बेटर, सो हम ये दवाई दे देते हैं. ठीक है. तो हमें एविडेंस मिल गया दैट 60% इज बेटर देन 50%. ठीक है. अब हाइपोथेसिस रिजेक्ट नहीं हुई, नल हाइपोथेसिस थी, बोथ आर सेम, हमने रिजेक्ट कर दी. रिजेक्ट कर दी मींस दैट मींस द रिजल्ट्स वेंट इन फेवर ऑफ द रिसर्चर्स थॉट प्रोसेस. ओके. अब रिजेक्ट नहीं हुई, उसने बोला 50% is not rejected, hypothesis, null hypothesis stands at 50% is same as 60%. कि आपने 60% डाल के कोई बहुत बड़ी बात नहीं कर ली, दवाइयां दोनों सेम है. It's a matter of chance what you're observing that 60% is on the higher side, but for all practical purposes both are same. So अब इसका ये मतलब नहीं है, अलग नहीं है वो दवाइयां दोनों, इसका ये मतलब नहीं है वो दोनों सेम है. सो एब्सेंस ऑफ एविडेंस, हमें एविडेंस नहीं मिला कि ये दवाई बेहतर है. इसका एविडेंस हमें हमारे रिजल्ट्स जो हमने जनरेट किए स्टैटिस्टिकल थ्योरी के बाद हमें नहीं मिले. तो इसका ये मतलब नहीं है कि एविडेंस ऑफ एब्सेंस, कि वो एविडेंस है अभी दोनों बराबर हैं ना, बराबरी की बात नहीं हो रही. हमें दैट मींस इन इफ इन कोर्ट culprit is brought to the court by the police and judge says, judge की hypothesis क्या होती है, the person is innocent, and if he doesn't have enough evidence to say that he is guilty, the person is acquitted. If a person is acquitted, does not mean that person is the court is certifying him as innocent. He says there is not enough evidence to say that the person did a crime, so he's scot free, but not with a certificate of innocence. So this is the same thing in statistics. If you're not able to reject the hypothesis, that means reject the hypothesis means what a researcher thinks has not happened does not mean that it is the other way around. Okay, आगे और चलेंगे तो clear होगी बात. Next, to steps alone, state the statistical hypothesis, select the level of significance of test alpha, यानी कि type 1 error, select appropriate test, perform calculations, p-value, provide statistics. So this is the methodology. This you'll be dealing in more lectures to come. Next, ठीक है. अब देखिए to study to determine the examples हैं. Study to determine association between coffee drinking and pancreatic cancer. अब वो क्या कह रहा है? The proportion of coffee drinkers with pancreatic cancer is more than the proportion of non-coffee drinkers. So this is the research. The researcher thinks this is happening. The statistics thinks other way. या नहीं बराबर है. अब हम करके देखते हैं. That means we try to prove something other way around. इसका क्या मतलब होता है? नल हाइपोथेसिस का मतलब ये होता है द स्टेटस को जो है वो बस वैसे ही है. There's something, nothing is new. न्यू को लाने के लिए we have to have that's just a matter of time. अगर ये रिजेक्ट हो जाता है then the researchers is awarded with that hypothesis. Okay, now you can go ahead with it, right? टेस्टेबल होनी चाहिए, वो सारी हम बात कर चुके हैं. नेक्स्ट, सो इसको हम मैथमेटिकली लिखते हैं P1 is equal to P2. अब 50% जो मैंने आपको बताया था 50% is equal to 60%. अब मैथमेटिक्स में देखा जाए तो इट लुक फनी कि 50% 60% के कैसे बराबर है, बट द स्टैटिस्टिक्स ट्राइज टू से कि these two things are same. You are observing 60%, but it's a matter of chance. Chance philosophical form, जनरल फॉर्म में कह सकते हैं जिसमें कोई मैथमेटिक्स नहीं है, बट मैथमेटिक्स इंट्रोड्यूस हो जाती है बाद में. सो P1 is greater than P2 और P1 is less than P2. इसका ऑल्टरनेटिव ये है. So this is an alternative hypothesis. After doing the calculations, we to arrive at a decision what is right, what we have to accept, and with what probability. Suppose next पे आएंगे फिर बता. So HA is written as the difference between the two proportions is different. P1 उससे ग्रेटर भी हो सकता है, लेस भी हो सकता है. सो दिस इज अ टू टेल टेस्ट जिसको हम बोलते हैं. ठीक है. नेक्स्ट, ठीक है. सिलेक्ट द लेवल ऑफ सिग्निफिकेंस. अब टाइप 1 लेवल ऑफ सिग्निफिकेंस क्या होता है? टाइप 1 एरर होता है, यानी कि प्रोबेबिलिटी ऑफ रिजेक्टिंग अ हाइपोथेसिस व्हेन इट इज ट्रू. ये जीरो नहीं होगा, ऑलवेज रिमेंबर. नॉर्मल डिस्ट्रीब्यूशन को अगर याद करें, इट गोज फ्रॉम माइनस इंफिनिटी टू प्लस इंफिनिटी. सो हम आपकी पहली स्लाइड में क्या था? डिग्री ऑफ अनसर्टेनिटी को मिनिमाइज करते चले जाते हैं. जब हम लिखते हैं ना P लेस, कन्वेंशनली वी राइट 0.05 एंड 0.01. इसका क्या मतलब है? हमने हाइपोथेसिस को रिजेक्ट कर दिया, यानी कि हमने ये बोला स्टैटिस्टिक्स को, हमने स्टैटिस्टिकल हाइपोथेसिस को रिजेक्ट कर दिया कि 60% 50% से ज्यादा है. भाई अब ये दवाई आप यूज कर लो, बेहतर है, उससे हमारे पास इनफ एविडेंस है. लेकिन इस एविडेंस में कमी कितनी है? 5% की. तो हमने एक साइंस ने एक कट ऑफ रखा 0.01 और 0.01 का, कि अगर ये एरर मार्जिन, दैट मींस टाइप 1 एरर 5% या उससे कम है, वी वुड कंसिडर दिस एज ए डिफरेंट. अब आप कहें कि जीरो क्यों नहीं कर लेते? जीरो नहीं कर सकते, हम इसको मिनिमाइज करते जाएंगे. 0.01 001 कहां तक जाएं? क्योंकि इंफिनिटी तक आई. तो हमने एक कट ऑफ बना लिया कि अगर 5% है तो वी वुड से द टू थिंग्स आर डिफरेंट. ठीक है. दिस इज कॉल्ड टाइप 1 एरर. यानी कि अगर जज ने उसको सजा दी, अब ये देखिए, यहां सोच के देखिए, उसके पास एनफ एविडेंस थे, 100 में से 95 एविडेंस उसको मिल गए उसके अगेंस्ट, एंड उसने उसको सजा दे दी. लेकिन हमने ये देखा होता है कि वो पॉसिबिलिटी बहुत कम हो. अब अदर वे है कि जज ने उसको छोड़ दिया कल्प्रिट को, लेकिन वो क्रिमिनल था, तो वो उस एरर को हम बड़ा कर देते हैं कि हम वो चांस लेना चाहते हैं कि इनोसेंट ना पकड़ा जाए। तो उस इसी तरह से हम न्यू ड्रग को रॉन्गली प्रिस्क्राइब ना करें, तो हम उस प्रोबेबिलिटी को मिनिमाइज कर लेते हैं। सो दैट इज कॉल्ड टाइप 1 एरर। दिस इज द बेसिस ऑफ होल टेस्टिंग ऑफ हाइपोथेसिस। आप जो पी वैल्यूज निकालते हैं टेस्टिंग ऑफ टेस्ट के करने का, उसका मतलब क्या है कि हम 5% गलत हैं इस कहने में। अब कोई कहेगा 5% गलत हो तो 1% कर लेते हैं, चलो 1 कर लेते हैं और कम कर लेते हैं, 0 तो कभी नहीं कर सकते ना, कहाँ रोकेंगे। तो हम एक कन्वेंशनल पे आ जाते हैं 5% या 1% पे, कि हम ये स्टेप उठा रहे हैं, लेकिन इसमें हमारे 1% या 5% गलती होने की संभावना, क्योंकि हम 0 पे जा ही नहीं सकते। नेक्स्ट, अब आपको ग्राफ्स में पता लगेगा। सो ये देखिए टाइप 1 टाइप 2 एरर्स कैसे लिखी जाती हैं कि H0 एक्चुअली ट्रू है और स्टडी रिजेक्ट कर रही है, ठीक है। Probability of rejecting a hypothesis when it is true, that means that both the drugs were same but you said they are different. So गलती होगी, और ये गलती होगी, ये कोई ऐसा नहीं है कि, लेकिन हमने इसको इस हिसाब से रखना है कि मिनिमम हो। और दूसरी एरर क्या है, probability of accepting a hypothesis when it is false. That means the drug was good but we didn't get enough evidence to prove it. So the error margin is this much. So that is called type 2 error. So 1 minus type 2 error को power बोलते हैं। ये शॉर्ट क्वेश्चंस एग्जाम में आते हैं, शॉर्ट नोट्स में, ठीक है। नेक्स्ट, सो देखिए हाइपोथेसिस टेस्टिंग के लिए नॉर्मल कर्व, जो नॉर्मल डिस्ट्रीब्यूशन का कर्व है, कि नेचर में डेटा ऐसे बना हुआ होता है, कुदरत ने ऐसे बनाया है एक ही लेवल का, तो एक फिलॉसफी भी इसमें आ जाती है। तो अब ये हम इसको रिजेक्शन रीजन मानते हैं कि अगर हमारी वैल्यू इस लाइट ब्लू पोर्शन में आ रही है, तो हम ये सोचेंगे यहां से बाहर जा रही है, क्योंकि ये पूरा इन्फिनिटी तक जा रहा है। तो हमें कैसे पता लगेगा, नेक्स्ट स्लाइड में और क्लियर हो जाएगी बात, नेक्स्ट पे जाएंगे, ठीक है। अब देखिए उससे हम इस पे आ गए। अब ये देखिए दो हैं हमारे पास ग्रुप्स, हमारी एक मेडिसिन के सक्सेस रेट ये है और उसका फ्रीक्वेंसी डिस्ट्रीब्यूशन ये है, दूसरे का ये है। अब देयर इज नथिंग इन दिस वर्ड जो बिल्कुल ऐसे हो, बिल्कुल कि ये दवाई इतना काम करेगी और ये दवाई इतना काम करेगी। चांस ये है कि ये दवाई गलत भी हो सकती है और ये दवाई जो हम जिसको सही नहीं मान रहे वो सही भी हो सकती है। ये एरर मार्जिन्स हैं और ये हमेशा रहेंगे, क्योंकि हम नेचर में प्रोबेबिलिटी 1 तक कभी नहीं जा सकते। तो हमने क्या किया, इसमें साइंस ने क्या सोचा, ये देखिए, ये एक ड्रग का सक्सेस रेट था, ये दूसरे का था। अब हम ये देखेंगे कि ये दोनों सक्सेस रेट जो हैं, जो कंपेयर कर रहे हैं, ये डिफरेंट है या चांस की बात है। अब हमने इसमें एक ऑब्जेक्टिविटी ढूंढी, हमने जो प्रोसीजर लगाने के बाद टेस्ट स्टैटिस्टिक्स लगाया, अब हमने एक कट ऑफ बना दिया। अगर ये यहां पर आ गई वैल्यू, यहाँ पे आपको कर्सर दिख रहा है, आई थिंक यू आर एबल टू सी, अगर यहाँ पे इस लाइन के बाद अगर आपका वैल्यू आ रही है, देन क्या करें, अब ये इसकी भी हो सकती है, इसकी भी हो सकती है, बट इसमें होने की संभावना इसकी बहुत कम है, तो हम इसको इस दूसरे का हिस्सा मान लेते हैं, इसका, ठीक है। और अगर इसके इधर आती है तो हम इसको इसका हिस्सा मान लेते हैं, कि दैट मीन्स दोनों ड्रग सेम है। लेकिन उसमें भी अगर यहां पर है तो पॉसिबिलिटी है ना, इसका हिस्सा हो सकती थी वो, तो इतनी एरर हो गई।
But how can you dance that you know bones only you will dance, sir? Practical that is
You want to ask any question?
In chat 2 and 1 you have sent me in WhatsApp, no, that how you are.
Any questions?
Muted, sir. Please continue.
अच्छा, okay, ठीक है। So this slide is whole basis of scientific testing of hypothesis. We talked about the concept, then slowly we narrowed down into the statistical concept कि क्या डिफरेंस है। अगर वैल्यू यहां पर आ रही है तो अब कैसे बताएं ये इसकी है या इसकी है, इट्स डिफिकल्ट। सो द साइंस हैज डिसाइडेड, द फिशर डिसाइडेड कि अगर ये वैल्यू इसमें आ रही है तो वी विल कंसिडर दिस। तो एरर कितना हुआ, तो इसको हम यूजुअली 5% रखते हैं, वी कीप दिस एज 5%, व्हिच इज कॉल्ड टाइप 1 एरर। सो इफ द टेस्ट स्टैटिस्टिक्स फॉल्स इन दिस रीजन, where you can see the cursor. So that means we are rejecting a hypothesis. We are saying that the 60% drug is better, but there's a 5% chance it might belong to this, but we will take a chance. क्योंकि इसका हमारे पास और alternative नहीं है, because the curves are not like this. Remember, it is like this. I hope you are able to see. It is not like this. ऐसे. So और अगर हम यहाँ पर आ रही है तो हम इसको इसका मान लेते हैं, लेकिन ये इसका भी तो हो सकता था. यहाँ पे हमने हाइपोथेसिस रिजेक्ट नहीं की, तो हमने रिस्क कम लिया कि अच्छी दवाई नहीं गई मार्केट में, कोई बात नहीं, लेकिन गलती से बुरी दवाई नहीं जानी चाहिए, तो हमने इस वैल्यू को हम कम रखते हैं, ये ज्यादा रखते हैं. ठीक है. So this is called type 1 and type. Probability of remember, probability of rejecting a hypothesis when it is true. We have rejected a hypothesis, the value comes here where you can see the cursor. ठीक है. But the possibility is that कि 5% chance है कि वो इसकी थी. And probability of accepting a hypothesis when it was false, that means the other जो second curve का जो left part है, so that means इतना error इसमें आ गया. Usually this is higher. That means we don't want to take a chance by getting a new drug which is not good. But if even it is a good and not given to the public, is reasonably acceptable. क्या अच्छी चीज नहीं गई कोई बात नहीं, लेकिन बुरी नहीं जानी चाहिए. तो ये एक लाइफ की फिलॉसफी है एक्चुअली, अगर आप उसके हम सोचें तो जज ने भी वही किया कि उसके पास एनफ एविडेंस नहीं था. कई बार हम कितने न्यूज देखते हैं, हमें पता होता है कि द पर्सन इज ऑन टू द फॉल्ट, बट द कोर्ट डजंट हैव एनफ एविडेंस टू से दैट टू पुट हिम टू अ ट्रायल, सो छोड़ देते हैं. सो दिस इज द कंसेप्ट. ओवरऑल कहते हैं, अगर देखा जाए तो फिलॉसफी ये लाइफ की फिलॉसफी पे ही बेस्ड है कि आप किसी चीज को गलत मत कहो अगर वो सही है, और किसी सही चीज को आपने गलत कर दिया तो कोई बात नहीं. तो ये मॉडल है. ठीक है. नेक्स्ट. So one tailed and two tailed, हमने ये देखा था कि जहां हमारा एग्जांपल था पीछे p less than p2, p greater than p2, हम था ना, proportion of the people with the pancreatic cancer in coffee drinkers and non coffee drinkers. अगर ये proportion हमने one side का टेस्ट करना है तो one tail होगा. अगर हम not equal to कर देते हैं तो हम less को भी टेस्ट कर सकते हैं. So it's always better to have two directional. बट ठीक है, जहां when you are sure that suppose आप किसी ड्रग को टेस्ट कर रहे हैं कि that this drug cannot be inferior to the other drug, improve होगी या वैसी होगी, तो आप वन डायरेक्शन कर सकते हैं. तो वन डायरेक्शन में सैंपल साइज कम चाहिए होता है, बट इट इज सेफर टू गो फॉर टू डायरेक्शन. द टू टेल्ड और टू डायरेक्शनल टेस्ट टेक्स केयर ऑफ वन डायरेक्शन, बट द वन डायरेक्शन डजंट टेक केयर ऑफ अदर वन. ठीक है. नेक्स्ट. सो टू टेल्ड में क्या होगा, म्यू1 म्यू 23 है, ऑल्टरनेट क्या है, म्यू इज नॉट इक्वल टू 23. लेफ्ट टेल में क्या होगा, एच नॉट इज म्यू ग्रेटर देन 23, h1 इज म्यू लेस देन 23. तो राइट टेल में क्या होगा, म्यू इज लेस देन 23 और ऑल्टरनेट इज. तो हम एक डायरेक्शन की बात कर रहे हैं. ठीक है. नेक्स्ट. सो क्रिटिकल रीजन्स, इनको हम बोलते हैं ना, ये देखिए, ये जो आपसे मैंने जिक्र किया था, तो इधर आ गया. अगर वैल्यू आपकी इधर आ रही है, इफ यू गेटिंग द वैल्यू इन टेस्ट स्टैटिस्टिक्स, जो आप कैलकुलेशन अगले लेक्चर्स में करेंगे, अगर वो वैल्यू इस जो हम कहते हैं ना क्रिटिकल वैल्यू 1.96 के ऊपर है तो सिग्निफिकेंट है, 1.96 के नीचे है तो इनसिग्निफिकेंट है. सो दैट मींस इफ इट इज कमिंग इन दिस रीजन, यू रिजेक्ट थिंकिंग दैट इट इज गोइंग आउट ऑफ दिस एरिया, बट देयर इज अ 5% चांस कि ये यहाँ को बिलोंग कर सकता है, क्योंकि इसका हमारे पास कोई तरीका ही नहीं है. तो हमने एक कट ऑफ बना लिया स्टैटिस्टिक्स में कि अगर यहाँ पर रेड जोन में आएगा तो हम हाइपोथेसिस रिजेक्ट कर देंगे, और व्हाइट जोन में आएगा तो वी वुड से नॉट रिजेक्टेड. दैट मींस हम न्यू डिसीजन को तभी लेते हैं व्हेन वी हैव एनफ एविडेंस. जब भी देखिए जो रेड एरिया है छोटा है, दैट मींस अगर टू पुट इट इन अ सिंपल वे, वी गो फॉर न्यू थिंग्स ओनली व्हेन वी आर वेरी श्योर वी हैव गॉट समथिंग एंड यू वांट टू रिप्लेस इट एट योर होम. यू वांट टू बी वेरी श्योर कि ऐसा तो नहीं कि नई चीज लाके फायदा ही ना हो उसका कुछ. इट कुड, देयर आर मेनी एग्जांपल्स टू इट, आई विल नॉट गो इनटू दैट नाउ, तो क्लास में होंगे तो बात करेंगे. तो ये देखिए. ठीक है. तो ये क्लियर. So a test statistics is a quantity calculated from our sample of data Sample, remember it. Its value is used to decide whether or not a null hypothesis should be accepted. So कैसे किया? इसके previous slides में आपने देखा कि वो value कहाँ जा रही है. So ये basis है. कैसे करना है बहुत आसान हो जाएगा. Computers available हैं. लेकिन क्या हो रहा है वो अगर माइंड में होता है तो you will be in a better position to write the results. The choice of test statistics depends on various factors. तो किस नेचर का डेटा है, कौन सा टेस्ट यूज करना है, chi-square करना है तो क्वालिटेटिव डेटा है, टी टेस्ट यूज करना है तो क्वांटिटेटिव है. तो ये सब चीजें अगर शुरू में क्लियर होंगी तो तभी हम ये सब कर सकते हैं. ठीक है. सो डेटा टाइप्स एंड स्टैटिस्टिकल टेस्ट ये हैं जिसके बारे में आई थिंक फ्यूचर लेक्चर्स में होगी बात कैसे करना है. तो मैंने आपको कोशिश की है कि आपको एक कैन गिव यू द बेस व्हाट यू आर डूइंग on this platform on which you're doing actually. That means I have given you the stage on which you're going to perform. Next. So definition of p-value. p-value type 1 error होती है कि हमने probability fix कर लेते हैं कि 0.05 से नीचे होगी तो हम रिजेक्ट करेंगे या 0.01 से होगी. That means error margin अगर हमारा 1% का होगा या 5% का होगा तो that is probability. कि जो हम डिफरेंस देख रहे हैं वो चांस की बात है वो कितना परसेंट है. Hope you're getting this point. The chance p is a chance factor. Before reading the actual definition, I'm just trying to put it in simple words. So p, what is p? P is a chance factor. That means we are saying that 60% is better than 50%. p less than 0.05 कि ये चांस की बात है कि 60 हमें ज्यादा दिख रहा है, इसकी गुंजाइश सिर्फ 5% है. तो हम उसको p वैल्यू बोलते हैं कि what is the chance factor. It will always be there, जीरो नहीं होगा. The probability of observing a value as extreme or more extreme than observed value assuming that the null hypothesis is true. Complicated लग रही है ना ये definition, but if I put it in a simple word वो यही है कि हमने कितनी वो value extreme तक जा रही है वो हमें decide करना. 0.05 से नीचे जाएगी तो we would say yes the differences are there. दो groups में difference है but we are wrong by 1% or 5%. But we'll have to take a decision somewhere. The smaller the p-value, less likely that the difference occurred by chance. देखिए जो मैंने explain किया आगे यहाँ पर. The smaller value, जितनी 0.001 हम कंप्यूटर पे SPSS में कैलकुलेट करते हैं, many times we get 000. Zero नहीं होती, never write zero. Write p less than 0.01 or 001. It will never be zero because of the format it is giving 0.00. So जितना कम है, that means ये जो difference हम observe कर रहे हैं, ये chance के बात है, उसकी probability बहुत कम है. So we can think that this difference is really difference and you can take a call. So that means hypothesis हमारी reject हो जाती है और हम उस पे decision पे काम करते हैं, rejection पे, कि what researcher thought in the beginning उस वो null hypothesis ने उसको reject कर दी. But वो extreme पे होती हैं वो चीजें. ठीक है. Always remember अगर वो reject नहीं हो रही तो वो दोनों same नहीं है. ये decision नहीं लेना कभी भी. ठीक है. Next. So alpha. So we always set the alpha value priori कि हम कितना चाहेंगे कि हमारा एरर मार्जिन टाइप 1 एरर कितनी एक्सेप्टेबल है. मेनी टाइम्स वी वांट टू बी वेरी स्ट्रिक्ट कि हम कोई चांस नहीं लेना चाह रहे, इस दवाई में साइड इफेक्ट्स ज्यादा हैं. जब p वैल्यू 0.01 होगी तभी हम इसको मानेंगे, हाइपोथेसिस को रिजेक्ट करेंगे व्हेन द चांस फैक्टर इज 1%. दैट मींस p is 0.01. So accordingly we'll have a critical value of 0.01 and based on the different test. So ठीक है. तो भी ये भी बता दिया 0.01 0.08 ये कन्वेंशंस हैं. 0.05 से हम स्टार्ट करते हैं, 0.001 हाईली सिग्निफिकेंट मानते हैं. 0.0 हाईली सिग्निफिकेंट का मतलब क्या हुआ कि जो चांस फैक्टर है, जो दो डिफरेंसेस को हम स्टडी कर रहे हैं कि वो सेम है, उसके होने की गुंजाइश 1% से भी कम है. एक मतलब 0.1% से भी कम है, 0.001 अगर आगे वैल्यू. ठीक है. सो इफ इट इज मोर देन 0.05 देन वी से कि एरर मार्जिन 0.05 है, यानी कि 5% से ज्यादा है प्रोबेबिलिटी कि ये, तो वी वॉन्ट रिजेक्ट द हाइपोथेसिस. दिस इज कन्वेंशन. बट ये डिसीजन क्लिनिकल एस्पेक्ट्स में भी लिए जाते हैं कि सपोज हमें लग रहा है कोई दवाई अवेलेबल नहीं है एंड वैल्यू समथिंग लाइक से 0.06, तो ये से आपकी मेडिसिन साइड इफेक्ट्स कम है और 0.06 आ रही है, सो इट इज अ क्लिनिकल डिसीजन व्हिच a group takes that okay let's consider 0.06 as significant and start with this drug. So this can be done only when you as a researcher understands the statistician and statistician understands the clinical aspects of it. So again, this is a handshake between the two when we work in research. Next. So level of significance के बेस पे हमारा decision होता है. I've already told you. Next. So the results of the study can be statistical significant, but still be too small to be any practical value. So suppose आपने 10,000 लोगों पे ट्रायल किया, ब्लड प्रेशर आपने 160 से 101, if you brought the blood pressure, average blood pressure from 160 to 158, there is a possibility because of large number, because of large sample size, there would be a statistical significance, but it may not have any clinical value. So in those situations, the statistical results are kept aside and the study is further taken up. That means if this drug is not working, numerically it is making a difference, but clinically that difference is not relevant. Okay. So justification of the p-value, I've already talked about it. So effect is too small, the results are statistically significant but not clinical. कि अगर difference small है बहुत और उसका standard deviation बहुत कम है, तो छोटा difference भी significant दिखेगा. But we have to see in the light of the subject on which the data is well based. So nature of data, the statistician also has to be familiar with the nature of data. Right? Next. So consideration for interpreting the results do involve epidemiologists and statistician, carry out exhaustive reviews of the research. तभी तो आप discussion लिख पाओगे and conclusion पे आओगे. Strengthen yourself with workable knowledge of the other subject. This is very important. I have to understand, your subject. Then only I can help you. And you can understand my concept when you have some. You may not, doesn't mean that you get into heavily into statistics, but understand the concept behind it. When in doubt, do involve more experts into the team. As a statistician, understand the clinician and his subject, and clinician should understand the concept of the statistical results. So results जो आए हैं उसको testing of hypothesis की theory पे base पे ही हैं सारे वो. P less than 0.01, P less than 0.001, P greater than 0.05. So उनको clinically हम merge करके we are write our conclusions. Next. So this is just alpha level कितने use होते हैं और उनके जो critical values होती हैं वो क्या होती हैं. 90% पे 1.6 होता है, 95% पे 2 tail में 1.96 होगा, 98% पे 99% पे 2.56. Suppose we want to keep p value at 0.01, हम critical value 2.56 लगते हैं. अगर हमारी टेस्ट स्टैटिस्टिक्स की वैल्यू इससे ज्यादा आती है, बी से सिग्निफिकेंट, तो ये तो एक रिमेंबर करने वाली चीज हो जाती है. तो कंसेप्ट मैंने बताया ना, ज्यादा का मतलब क्या हुआ, दैट मींस दैट वैल्यू मूव्ड इनटू द जोन व्हिच इज लेस देन 0.05. सो हमने रिजेक्ट किया, थिंकिंग दैट इट विल टेक अ चांस दैट दिस इज गोइंग टू a different group. I hope you're getting. Now connect this values with the slide earlier, and you'll be having slides, of course, with you. That curve, that red portion. So 2.57 से ज्यादा जाएगा, that means it has come into that red portion. So it belongs to the initial group. The chance is very less. So we will say, okay, this drug is better than. Let's take a chance, but we are sorry by 1%. Okay, next. So thank you so much. You have my email, and thanks for your time. I think I talked many times in a very general way. I hope the organizers and the participants don't mind. If something informal was there and if you didn't like, sorry about it. So thank you so much, friends. Thanks, organizers, too, for the honor.
Thank you so much, sir. Thank you for enlightening us, and thank you for sharing the concept in an easy and effective way. So I think in this way we can understand more easily the concepts. In general,
tried.
I'm always learning something new. I'm attending all lectures when you are in that lectures presenting.
So kind of you. So kind. Actually, I mean, this is actually, Tiwari, so whatever I have tried to present, this is based on my experience with the participants. So इसमें किसी को बुरा नहीं लगना चाहिए, क्योंकि कई बार स्टूडेंट्स बात करते हैं तो वो पता लगता है कि वो ऑब्जेक्टिविटी में बात नहीं कर रहे हैं. तो वो फिर मैं अपने लेक्चर में इंट्रोड्यूस कर देता हूँ कि जब हम इंटरेक्ट करें तो हम दोनों एक दूसरे के साथ ऑब्जेक्टिविटी और p less than 0.05 का मतलब क्या है, बस सिग्निफिकेंट है, that's good enough. Not that. You should understand what it means actually.
Definitely, sir. Definitely. And also all participants also replied in the chat box, and they are very thankful for such a nice presentation. Thank you, everyone.
Thank you, friends, for your very, very kind words. this always encourages a teacher. And I look forward to meeting you whenever we get a chance. Classroom interaction, there is nothing replaces the classroom interactions. We can ask
Definitely, sir.
questions, we can see the faces and encouraging faces, disappointed faces. So in that way, the teacher also learns actually.
Definitely, sir. An Institute of Applied Statistics in this way, Institute of Applied Statistics is working to start annual conference in 2025, maybe in February and March. So all delegates who ever anytime attended any session, they join us freely and attend the one lecture over there.
That's a wonderful thing you're doing.
So
Thank
Institute
you.
and management is working on that.
My thanks and appreciation to the whole management. Convey my regards to your bosses
and this is not possible without your support, sir. Always taking guidance from you and all our
thanks.
respected members. So thank you, everyone. Thank you, sir, again for your time and valuable time and expertise in this program. And thank you all delegates for listening very patiently and replied in the chat box in a very positive way. So thank you. This is the end of today's session. If you having any doubt, you can mail, you can WhatsApp me, you can write us in any format as per your convenience. And tomorrow there is a quiz 3 schedule, and the link will be shared in the WhatsApp group. You can attempt the quiz 3, practice yourself what you learn till this month. And the day after tomorrow, we have one another session scheduled as per the browser. The second topic of inferential statistics, that is testing of difference parametric test, and it will be delivered by Dr. Kalpana K. Mahajan ma'am. So be on time. Tomorrow there is a quiz, and the day after tomorrow we again start at session on second session of inferential statistics at 6 p.m. Thank you, everyone.